This is the Algebra 1 STAAR study guide, lesson 4.1. We only have about 5 left on these. And this is about quadratic functions, which, if you remember, quadratic functions are these parabola shapes. And the biggest thing you need to know is what a vertex is. The vertex is either the low or the high point of the graph, depending on where it opens. So if the graph opens up, there's a vertex here at the bottom. If it opens downward, then it has a vertex here at the top. And that point is kind of the most important point, I would say, on that graph. And so you're going to be looking at these functions and basically matching up these points with the equations that they give us. So we'll do this first one, and I'll let you do the rest. So they tell us they have a vertex at 1, 1 and a point, just some point at 3, 9. So that point 3, 9 needs to be on the graph. So let's go ahead and put those points in here. 1, 1, and 3, 9. So what's cool is that I can put more than one point in one line like that. Notice I just put a comma between them and it has both of those points there. So then I need to take these equations and plug them in one at a time to see which one actually goes here. So we have 3x plus 9 squared plus 1. 3 parentheses x plus 9 squared. And to do squared, you're going to do shift, press the number 6, which is the little caret shape, and then squared, and plus 1. So clearly that doesn't match. It doesn't cross these points. So we'll go to the next one. 2x minus 2 squared plus 1. So 2, this needs to be changed to a 2, and this needs to be changed to a 2. Okay, still not there. Still shifted too far over this way. So let's take a look at this. 2x minus 1 squared plus 1. So the 1 there is still the same as 2x minus 1 squared. And we can see we have that point there, and we have this point here, which are both on the graph. You can't see it right now, but if I change over to green, you can see both of those points are on the graph. So that's our third answer choice. And that's what you're doing for all of these. You just need to match the quadratic function graph with the points given here. Do that for number 2. Number 3, you just need to match the graph here with the graph that you get when you graph these. So that's even easier maybe in some ways. So graph these on Desmos and match it with this picture. Same thing with number 4. So I'm not going to do any more of those. You're just graphing them, matching the graph with what you have in the problem. Then it gets into questions about domain and range. So this is fairly conceptual, but basically the most important thing you need to understand is domain. When you talk about a domain of a function, you're talking about the x values. You're talking about how this graph, for how far it goes in the x direction. And that's going to be your domain. And then your range is how far the graph goes in the y direction. So that's the domain. And so when you are asked to find the domain and range in here, you're just going to be using that kind of concept. So it says a parabola has a vertex at -4, -5, and points up. Both endpoints have arrows. Okay, that's significant because anytime it says both endpoints have arrows, you know that your domain is -infinity to +infinity. So right away, I'm crossing out the first answer choice because the domain doesn't have infinity. So it's got to be one of these 3 down here. So that's what that tells me. This tells me that the domain is positive and negative infinity. So just remember that as you go. What is the domain and range of the quadratic function? So the key here is to understand what these numbers tell us about the range. So first of all, we know the range is y. So we won't be looking at the -4. We're more interested in the -5 because the -5 is the y value. So this graph opens up. Sorry about that. The important thing here is that the y value here is -5. I'll clear that out. Try to draw that a little better for us. So the graph opens up and it has arrows, which is fine. So what we know is that the graph goes forever up, but it has a low point at -5. So that means it can't be the second choice because it has -4 as the low point. The low point here is -5. Now notice one of these has y is less than -5, and one has y is greater than negative 5. And since the graph opens up, the graph appears above negative 5. It's greater than. Here's negative 5. The graph is above, so that's why we're choosing the fourth answer choice as our answer. So that's kind of what you're doing, and that's how you're going to do number 6. I would just draw this out, do a brief sketch of it, and answer it that way.